Hey, I'm Jonathan Oxer, and this is SuperHouse. Now, if you're into DIY home automation, you've almost certainly come across the Sonoff. It's a little Wi-Fi enabled power control device. You simply splice it in line with the power to something, and then you can control it. The Sonoff comes with software called eWeLink. The firmware that comes on the device itself is designed to talk to the eWeLink app, which you can run on your phone. That's really good for basic things, but to really unlock the power of this device, it's best if you can put your own software on it. That gives you total control. You can add new features, you can link it into your own home automation system, and you don't need to have it connect out to the internet in order to control it. Now, there are a whole lot of different Sonoff models. This is the Sonoff Basic, which is the most common one. It's just Wi-Fi control of a single channel. I've got a whole collection of them here. There's the TH10 and the TH16, which have the temperature and humidity sensor inputs. There's a 4-channel Pro, which is a DIN rail mounted relay, normally goes inside a switchboard. It gives you 4 outputs. There is the Sonoff Power, which measures power consumption, so not only can you control devices, but you can see how much power they're using. I also have here the Slamper, which is a Sonoff in a strange form factor. You unscrew a light globe, screw this in its place, put the light globe back in, and now you've got Wi-Fi control of a light globe that wasn't set up for it previously. And I've got the little touch controls. Use these to replace the light switches on your wall, and then you've got control from your home automation system. But the thing is that replacing the software on these can be a little bit tricky. You need to find the connections inside, so you've got to open them up, find where the headers are, make the appropriate connections, and load the software. What I'm going to do is take you through each one of these models, open them up, show you where the headers are, and exactly what you need to do to reflash the software for each model. Now, in some situations, you can update the Sonoff using over-the-air or OTA updates. That means that you send the new software to it over the Wi-Fi connection, and you don't need to make any electrical connections to the board itself. However, that only works in certain circumstances. The best way to get your own software onto it the first time at least is to connect directly onto the PCB and use a serial upload. But first, a word about safety. The Sonoff is a mains powered device. It will have lethal voltages connected to it while you have it linked to any device that you are normally controlling. Never ever plug connections into it and try to reprogram it while it is powered from the mains. Always make sure it's disconnected and only powered from the connections that I'll show you in a moment before you try reflashing it. All current Sonoff models use either the Espressif ESP8266 microcontroller or the ESP8285, which is based on the same core. It's just got some built-in flash memory instead of using external flash memory chip. Because both the 8266 and the 8285 use the same core, they can be programmed in the same way. They can be put into a special bootloader mode where they'll accept a new program over a serial connection. The ESP8266 has 3 pins that are designated as strapping pins. It checks the state of these pins when it first powers up, and that controls what mode it goes into. In just about every ESP8266 based design, you'll see something like this. Typically, GPIO 15 is pulled down to 0 volts, GPIO 2 is pulled up to 3.3 volts, and GPIO 0 is also pulled up to 3.3 volts. The one we care about now is GPIO 0, because if that is pulled low, it will force the ESP8266 to go into bootloader mode. So many designs include something like a button that will pull it down to 0 volts. Then all you have to do is hold the button in while the system is powering up, and it will go into bootloader mode. Once it's in bootloader mode, it'll be ready to listen on the TX and RX pins for communications with some serial link which will upload a new program to it. So by connecting to TX and RX, and by forcing GPIO 0 low in the Sonoff, we can force it to go into bootloader mode and load new software into it. The really cool thing is, now you know how to put the ESP8266 into bootloader mode. It doesn't matter what model of Sonoff you're trying to do this to. In fact, IT could release a new model of Sonoff 5 minutes after I upload this video, and it doesn't matter. As long as it's got the ESP8266 processor, and you can find ground, TX, RX, and the GPIO 0 pin in order to put it into bootloader mode, you can reflash it. If you want to write your own firmware to run on the Sonoff, that's great, but there are plenty of ready-to-go options. The Tasmota firmware by Theo Arens is legendary. It's got lots of features. It allows over-the-air updates. This is the one I personally use. Esperoino is another option, and ESPerna. Both of these are good alternatives to eWeLink and let you control it from another home automation system. There's also Pete Scargill's ESP MQTT code, which he uses in his extensive home automation system, so that's definitely worth a look. And Node MCU, which allows you to write whatever you like using Node. However, this video is not really about the software. So whatever you need to do to set up your software environment, you need to follow the instructions for the appropriate firmware. The first model we'll look at is the Sonoff Basic. A lot of people have got these. They're really common. So we'll just treat this one as if we don't know anything about it and we want to try to figure out where the connections are. Start by pulling it apart. This is a brand new one, straight out of the box. Sometimes they've got a warranty sticker across here. This one doesn't, and I don't know why. It's very easy to get apart. Just use your fingernail or a screwdriver or something. Shove it in here around the edge of the case, and it all just clips apart. And this is the bit that we care about. So here we have the input on the left, output on the right, and there's the power supply which runs the circuitry on the Sonoff itself. And then if we turn it over, that is the ESP8266 chip, which is the one that provides Wi-Fi, and it's the brains of the unit. And you can see the trace antenna on here as well. So what we want to do is figure out how to get new firmware onto that chip. Now, this is already well documented on the Sonoff Basic, but just let's imagine that we'd opened this for the very first time and we've never actually seen this board before. How would we figure out how to get software onto that chip? Well, we know what the pinout is on the microcontroller itself. So we can start by tracing connections out from the MCU. So if we chuck it under the microscope, we can find out where they go. So with the Sonoff under the microscope, we can see here the ESP8266 chip. And you can also see here a little dot. That's pin 1 just over here. So that indicates the orientation of the microcontroller. The pin numbering starts from here. It goes down 1 to 8, 9 to 16, 17 to 24, 25 to 32. Now from the ESP8266 datasheet, we know that pin 25 and pin 26 are RX and TX. So 25 is right here. That is pin 25, which is the RX pin. Next to it is TX. So if we trace along here, we can see that the RX pin comes down to this big pad. The TX pin comes to this big pad. So that means that this connector that you can see, well, there is a row of 5 holes in the PCB. One of them is TX and one of them is RX. So let's dig a little bit further. Now, just down here, you can also see this one has got connections through to this polygon. That's a giveaway that this is probably the ground connection. So far we've got ground, we've got TX, RX, and we don't know what this one is. And also we need to find GPIO 0 in order to be able to put this into bootloader mode, because we need to pull GPIO 0 low while it's booting in order to put it into the right mode. Now GPIO 0 is on pin 15, which is this one right here. If we follow along that trace, we can see it comes along to here. There's a 1K resistor there. It also comes through here, it runs up to there, and then to a via, so it ducts through to the other side of the PCB. So if we turn the board over, we can see that it comes through right here, comes across, and then ducts back down again. So we'll turn it back over here, and we see that that via comes up here, and then there's this little trace. It goes along the PCB and ducts back down into another via. This is a bit of a detective job, so we know we're just near that hole there. So if I turn that over, and that hole is on the bottom of a part that's not placed, but this right here is the via where it comes up. It goes to a pad that's not populated, goes through a 0 ohm resistor, back up to here, and down to yet another via. So let's drop back down under the board yet again, taking a long circuitous path, and then from here the trace comes along and all the way down to the bottom part of the board, right down here, and you can see it's right down near this other 1K resistor, and it connects through to yet another via. So if we turn the board over, let's see where that via goes. It comes to here, and it's connected to this switch, well, this little push button. Now this is the push button that you use to put the Sonoff into like programming mode, or that you press to turn it on and off. And you can see the other side of the switch is connected to the ground plane. That means that the button on the Sonoff, when you press it, will pull GPIO 0 down to ground. Now that is exactly what we want to put it into programming mode. And now what we still need to find is the 3.3 volt supply, because we need to be able to power up this ESP8266, but we don't know where it's getting its power from. Now we can trace out a couple of things, but let's just have a look around the board. We don't have to look very far until we find this thing right here, and it says 1117 3.3. That's a bit of a giveaway. I happen to know that a 1117 is probably something like an LM1117, which is a 3.3 volt linear regulator. And the big pad on that is the 3.3 volt output. So if you can find the voltage regulator that's on the board, then you can probably find the supply to the ESP8266. So I've got my multimeter here, and I've got it set in continuity test mode, so you might be able to hear that beep being picked up through the microphone. So we can just look around now and see somewhere handy that we can pick up 3.3 volts. Now of course we could just solder straight on here somewhere, but it's probably somewhere more convenient. And we can see that this is the 3.3 volt output, and this test point 1 here, TP1, is 3.3 volts. Now we also know that pin 1 on the ESP8266, which is right here, is 3.3 volts. So just to verify, I'm going to put the contact on there from the multimeter, and I'll touch up here on test point 1, and you can probably hear that the multimeter is telling us we've got continuity. So the 3.3 volt supply to the ESP8266 is definitely available here. Now, a little bit of poking around, and very suspiciously, of course, we think that we probably have the connection on here. So we know that this is the ground connection, it's not that one. This is the RX and TX pins. So let's go from the test point and check this one. No, we don't have any connection there. And this is the other one. And you can hear that that is connected to 3.3 volts. So that means that now we have the 3.3 volt connection as well on the on that little header. So I think we're pretty well set. We now know that ground is coming in here. We can tell that just by observing the connection to the polygons. We know that TX and RX come in here. We can tell that by tracing the connections through to the ESP8266. We know that 3.3 volts is here. And we know that GPIO 0 is connected to this button. So if we push that down during power up, it'll go into bootloader mode. If you're curious, there's an extra pin at the top. That's GPIO 14, but we don't actually care about that right now. And now, knowing absolutely nothing about the Sonoff until we opened it right now, we've traced through and found all of the connections that we need to put it into bootloader mode and upload new software to it. So if you get a new Sonoff model that you've never seen before, you can follow the same principle. You can trace out the connections from the ESP8266, figure out where they go, make yourself a little diagram of where the connections need to be. To connect to the Sonoff, we need something like an FTDI cable or something compatible. It's got a serial connection on one side and a USB connection on the other. The FTDI serial header is a bit of a de facto standard in the hardware community. It provides a 6-pin connector with RTS, RX, TX, Vout, CTS and ground connections. Many boards have this exact header on them to match up to FTDI type adapters and the many clones that are available. The Sonoff also has a serial header, except that it's only got ground, RX, TX and 3.3 volts. So what we need to do is match up the connections between these two headers. Connecting ground is easy. We just need a single ground reference between the two. And then we need to supply 3.3 volts to the Sonoff. That means we have to use an FTDI adapter that will provide 3.3 volts on its power output, not 5 volts. Next we connect the TX line from the USB to serial adapter to the RX line on the Sonoff. This is something that trips many people up. You have to remember that you are swapping the TX and RX lines because transmit from one side is receive on the other. Likewise, we take the RX line from the USB side on the FTDI header and connect it to TX on the Sonoff. We can also optionally put a switch in line with the power connection. This allows us to power cycle the Sonoff. So this little adapter that you can see here is what allows us to connect the FTDI serial header to the Sonoff serial header and then load new software onto it. By following that diagram I just showed you, you can make up a cable like this one. I've just used a 6-pin header on one end, 4-pin header on the other, some ribbon cable and a switch. This is essentially the same thing as we've just looked at as a diagram. Then if you've got an FTDI compatible adapter, something that will run at 3.3 volts, not 5 volts, you can just plug that in and you're ready to go. However, I'm going to use this little board. This was designed by my friend Luke Weston. The nice thing about it is that it has a switch that lets you select either 5 volt or 3.3 volt mode. By putting it into 3.3 volt mode, it will only supply 3.3 volts out the power line, and the logic lines will only be at 3.3 volts as well. So what we can do is pair these up, and then we're ready to connect up to our Sonoff. Just plug in USB. But because I've had so many people ask me to make these cables for them, I've ended up designing a PCB that does the same thing. This PCB is logically the same as that cable. It's got the 6-pin connector on one end, 4-pin serial connector on the other, and I've got a little jumper on here so that you can isolate power if you want to. So all you need to do is use an FTDI compatible USB to serial converter, plug this in, and now you've got a header that is compatible with the Sonoff. Now, as we've already seen, all the connections we need for the Sonoff Basic are right here on the little header. And just for convenience, what I'd like to do is get a 1x4 female header and solder it in place. The Sonoff doesn't normally have anything in there. At the factory they probably just use pogo pins or something. But what we can do is get a 1x4 header. I'm going to jam it in there with a bit of blue tack just to hold it in place, and then solder it in. So let's come over here and solder these connections in place. This will give us the 3.3 volt TX, the RX and the ground connection that we need. And GPIO 0 is on the button. So now we can plug straight into there. And with our little adapter, this is the USB to serial adapter with the converter on it. All we have to do is plug in. And as you can see there, this has powered up the Sonoff through the serial connection. And if we put it into programming mode, we can now upload to it. So to put it into programming mode, you need to have GPIO 0 held low during power up. And we can do that either by taking off this little jumper that isolates the power connection. And then you press down the button and hold it, put the jumper back on, let go, and now the Sonoff is in programming mode. So we could upload Tasmoda or whatever other firmware you want to. I put this on here just for convenience so you can isolate power, but practically what I find myself doing most of the time is I just leave that in place and all I do is unplug it. So what you can do is just press down the button, plug in the programming adapter, let go, and you're done. So that is now ready to accept and upload. And that's how easy it is for the Sonoff Basic. Now the Sonoff PAL, the TH10 and the TH16, physically they all look like pretty much the same thing. They're in the same case, and the PCBs have got a very similar layout, so they have the connections in the same place. So what we're going to do is just look at one of them and use that as an example. The same thing works on all of them. Now to open up any of these, I've got a Sonoff PAL here, brand new straight out of the box. And we need a screwdriver with this one. You can't just clip it apart like you can with the Sonoff Basic. Got to get that cover off. You can clip the main body apart, but then as we'll see in a second, the PCB itself is screwed inside the case. Unlike with the Basic where it's just clipped in, it's held in by the case itself. So we have to undo these 4 screws in order to get to the bottom of the PCB. You can actually see the connections even without doing this. Just down here you can see that it's got a label that says VDD, and up here it says ground, and the two in the middle are actually TX and RX. So this one has an almost identical layout to the Sonoff Basic. The difference is that on the Sonoff Basic it's got a 5th hole just up here, which is GPIO 14, but otherwise this is the same as the bottom 4 holes on the Sonoff Basic. So if we get one of our 1x4 headers, solder it in place here, then we can use the exact same adapter, the little thing I showed you earlier. We can just plug this in and reprogram it. So I'll just solder this connector on, find myself a bit of handy blue tack once again. Very good for holding things in place so that you can solder them and not have them fall out while you're working on them. And that's all there is to it. And just like on the Basic, the Sonoff Power has GPIO 0 connected to the button. This is the mode button that you can access from outside the case. So if we hold this button in and then we connect in with our USB to serial adapter and either the little cable that I showed you how to make or one of these boards, let go of the button, it'll be in programming mode. And now I'll just quickly show you the inside of these, just so you can see how similar they are. So there's the Sonoff Power with the new connector. This is the TH10. I had already soldered a connector on there, and this is a TH16 which hasn't been modified. So if I was going to reflash this, I would probably solder one of these in. Now, one of the things that you might choose to do is not put one of these connectors in place. If you make up an adapter cable like this, you can just use these pins directly. So we could insert these into the holes on the PCB, and then just by applying a little bit of sideways force, doesn't need to be very much at all, you'll see it flops around there, but if we just push it gently and hold it, we can then use the programmer and reflash it. That way you can reflash it without even having to solder the connector in place. Personally though, I like putting these connectors in because it means that you can just plug this in and you know it's got good electrical connection. All the Sonoff models we've looked at so far have been pretty straightforward, quite easy to deal with. Let's look at something a bit more exotic. This is the 4-channel Pro. It's not designed to be mounted standalone, although you can do that using these screw terminals. It's designed to be mounted inside a switchboard, which is why it's got these DIN rail mounts. And it's got 4 outputs instead of 1. So you supply power in here, and then you've got 4 switched outputs. So we've got 4 buttons to turn the outputs on and off individually. So that's all pretty straightforward if you're going to use it in its normal sort of setup, but we want to replace the firmware. So start by unscrewing this to get inside, and then we'll see that things are not quite the same as your typical Sonoff models. Not quite enough. There we go. Get the cover off. So we can see here the 4 relays that are used for the outputs, status LEDs, the buttons for turning the outputs on and off, and the connections. But when you look at the circuitry, you see that it's a little bit odd. Firstly, where is the ESP8266? Well, there isn't one. There is actually an ESP8285, which is that other model I was telling you about earlier, and it's on this module right here. So if we jump across to the microscope, chuck it under there, see if I can get a bit of focus happening. Something like that. Okay, so this is the module which contains the ESP8285, and it sits on top of the main PCB. You can see it's got these little castellated edges on it, so it's soldered down basically as if it's like an IC, but it's a little sub-circuit board with the ESP8285 on it. You can buy this module yourself from IT. They sell it as a development module so you can build it into your own products. And if I lift this little bit of sticker just here, normally there is a socket on here so that you can plug in an external antenna, because there is no antenna on this module. But what they've done on this product is they've put a trace antenna onto the main carrier PCB, and then that's connected down through one of these connections. I assume it's this one right here, so that the module itself uses the carrier PCB for its antenna. And just across from here, well, what do you know, we've got a little 5-way connector again. And once again, it's got ground, TX, RX and 3.3 volts. Also has SDA up here. Now on the Sonoff Basic it had a 5-pin connector, but it was actually, if you had it oriented the normal way, it was up the other way. So if you're used to looking at a Sonoff Basic, it would be a 5-way connector, but the GPIO connection on the Basic is up here, GPIO 14, and this bottom one isn't here. So what we're looking at here is the equivalent of the bottom 4 pins on that connector on the Sonoff Basic. So if we grab one of our 4-way little headers and you solder this in here, once again, now if I slide this back over to the other camera so that we've got a better overview, what this does is provide us a place that we can plug into it. So, of course, got to do the standard thing, grab the trusty blue tack, heat up the soldering iron, and we'll be able to solder this header in place. But don't jump ahead too quickly, because there is a trap. As I said before, this is upside down compared to what you might be expecting to see on the Sonoff Basic. With the Sonoff Basic, you have the ground at the top, 3.3 volts at the bottom. So if you grab the little adapter cable or adapter board like this and you plug it in this way, it'll be reverse polarity. You'll have ground and 3.3 volts connected, which is really bad. So it needs to go in this way instead. Essentially it's going in upside down. So for now I'm just going to solder this connection in place. It's a bit backwards from where I'm sitting, so it's quite hard for me to see this. The bench setup is not really all that convenient when you're trying to orient things for the camera and not for human use. So now we have that header with 3.3 volts at the top, and on the little breakout that I've made you can check whether you've got the orientation correct anyway, because on the silk screen I've got ground, RX, TX and 3.3 volts. Now remember also that RX and TX are from the point of view of the device. So RX from this module's point of view going in this way is actually TX coming out of the Sonoff. So if we turn this Sonoff 4-channel Pro upside down, ground and ground match up, 3.3 volt and 3 volt match up, and TX from the Sonoff goes to RX on the module, and RX from the Sonoff goes to TX on the module. So we plug it in that way, then we could use a USB to serial adapter, and everything's good. Disconnect power and power it up and put it into bootloading mode. But, okay, now we've got a complication. We need to pull GPIO 0 low on this. And this is where one of the other interesting things about this design comes in. Now the ESP8266 and 85, which are essentially the same thing, have very, very limited I/O. One of the difficulties that IT faced when they were designing this board is they needed enough outputs, they needed status LEDs, they needed the input buttons, and there just weren't enough I/O pins on the 8266. So what they did was drop another processor onto the board. It's this one right here. Let's check this one under the microscope. It is that little processor. Now if I adjust the lighting, I just have to get the lighting right for the microscope. You can just make out that it says STM32. It's an F030 something something, and that is a little STM32 microcontroller. And what they're doing is using this as an I/O expander. So if we come back across to here, the main brains of the system is the ESP8255 in here, and that's what we can reprogram through our little header. and the STM32 is being used to interface with the different devices. So the 8285 sends commands to the STM32, and that then does what it needs to do. So that's a really handy little design trick if you want to use the 8266 or the 8285 for Wi-Fi and general control of your project, but you run into I/O limitations. You can slave a second little microcontroller there and use that to control whatever you need to. But now we need to put this into bootloader mode, which means pulling GPIO 0 low. Now on this version, this is the 4-channel Pro. There's also a 4-channel Pro R2, which is slightly different, but I don't have one of those. On this one, GPIO 0 is on the top of this little module, and it's the second pin from the right. So once again, we'll chuck it back under the microscope and use a little bit of solder as a pointer. So this is from the bottom of the PCB. You can see the module there. That pin right there is GPIO 0. So that is the one that we need to pull low. But how do we connect to it? There is nothing else nearby. Well, this is where you need to get a little bit creative. So what I'm going to do firstly is I'm just going to touch that with the soldering iron to put a little bit of extra solder into there. So nice bit of fresh solder into that joint without bridging it across to anything else. And that will make it easier to get a little bit of wire and solder that in place. So what I'm going to do is find myself an old jumper wire. What have I got? I've got a little orange one up here. This will do, and some cutters. So I'm going to take this little jumper wire, cut it in half, and strip back a little bit of the end so that I can then tin it. So I'll just get a bit of solder onto there, trim it back so it's nice and short, back under the microscope, and here you can see once again our little module. So I'm now going to solder the end of this wire onto that pad right there. Now let's get the brightness up a little bit so we can see what's going on. Here we go. So I'll just keep it butted up against the pad, get the soldering iron in there, and reflow it. So now we have this jumper wire connected to GPIO 0. Now we need to pull it to ground, and if we look around the board we can find some other headers around the place. Now just across from the STM32 you can see a couple of 4-way headers here. Now this one is actually the programming header for the STM32, so you can reflash that as well if you want to, but we don't need to for our purposes. But we can easily find a nice convenient ground connection here, and it's even labelled for us. So what we can do is, in order to put this into programming mode, first up we use our USB serial adapter and get that ready. Then we take this jumper, put it into the ground connection right there. Just make sure it's got a good electrical connection. We plug in our cable. Oh, I've got to do it around this way, that's right. And if it's then powered up from this little USB to serial adapter, which I can do right now if I grab one from here. Got to remember to put it in the right way. Don't put it in this way, which is the way that feels natural, because you'll have the polarity reversed. It goes in this way to match ground to ground. And then that is now in programming mode. So after a couple of seconds, we pull out the jumper, make sure it doesn't touch anything. And right now, this 4-channel Pro is in programming mode, ready to accept uploads. And it's as easy as that. Now once you have finished doing your programming, you will probably want to remove this lead, because you don't want this lying around inside the box ready to short against anything. So what we'll do is just chuck it back under the microscope and I will take that lead off. It's gone. And then once you have alternative firmware on here, if you've uploaded something that allows over-the-air updates, you can then do updates whenever you want to. You don't need to re-solder that connection every time you want to do an update, because all you do is connect to it over the Wi-Fi, send it the update, and it'll load it and then reboot and ready to go. Now if you have a 4-channel Pro R2, you do a very similar thing. It's just that the GPIO 0 point is brought out to a nice little test point. And also the R2 doesn't have this module. It has the processor sitting directly on the main board. They integrated it for that revision. But the test point just makes it an easy place to solder onto instead of having to solder onto the little castellated edge there. So if you want the details for that, I don't have it in the video, but make sure you look at the link in the video description, which takes you to the page on the SuperHouse site. And there I'll have photos, diagrams and pinouts and everything for showing how this works on all the models that I'm showing in this video. So far we've looked at pretty conventional models, but let's get right out there. This is the slamfer, which is the thing you stick in line with the light globe, screw it into a normal socket, and it gives you Wi-Fi control of your lights. Now with this one, we've got to go straight for the screwdriver to get it apart. It's got a couple of screws on the back here, so we'll just pull those out and see what we can find inside. This is quite different to the normal form factor of a typical Sonoff, but electrically it should be pretty much the same. It's got a funky round PCB, but apart from that, this is really just like a Sonoff Basic. Well, a Sonoff RF, it's got this module in here. Now one thing that's a little bit strange about this one is that this is an early prototype. If you look on the PCB, just down here you can see it's version 0.2 slamfer, and IT were nice enough to send me this when they were first prototyping them, and I think they're currently up to version 2.0 is the current release, but nevertheless electrically they haven't really changed. And if you turn the board over, what you can see just over here is a little 4-way header, and amazingly it's in the same format as all the 4-way headers we've seen before. In this particular one, I've already soldered one in here. I've soldered the little sockets in there. Normally it's just a row of 4 plated holes, so you can solder in the header if you've got it, if you've got one of these, or just leave it and put the pins through the holes. So on this particular one there are no markings on the silk screen, so you can't actually tell which end is ground, but a little bit of checking with the continuity tester and it's pretty easy to tell that this end is ground, this one up here, and the other end is 3.3 volts. So to connect our little adapter, if we wanted to connect this up, we've got ground at this end, 3.3 volts down here. So the orientation is basically like this. The marking on this end of the header aligns with 3.3 volts, and if we plug that in, we can power it up and communicate with the processor. But there's a bit of a problem. One thing that is different about the circuit for this one is that the button on this is not connected to GPIO 0, and as we've seen already, we need to get to GPIO 0 in order to pull it down low and put the Sonoff into bootloader mode. Now if we turn the ESP8266, I'll turn the board over so we can see the ESP8266, which is right here. Let's see what we can find. Chuck it under the microscope, see if we can get some focus. There is the ESP8266 right there. And if we look up in the top left corner, you can see there's a dot on the case of the microcontroller. That signifies that this is pin 1 right here. Now we know that GPIO 0 is on pin 15. Counting down this way and then across the bottom, it is the pin that is second from the right, just there. Now we can see that there is a trace that comes out and it comes to this resistor. It says 102, which means that's a 1K resistor. And it comes, the other end of the resistor comes to here, this end of the capacitor. This is 3.3 volts. So that is a pull-up resistor on GPIO 0. So we need to be able to pull that low in order to put this into bootloader mode. So let's start by grabbing the soldering iron, and we'll just freshen up the solder on that joint so that we can make a connection to it. And I've got this little jumper wire right here, so I'll solder this onto the end. It's a little bit tricky because I can't really see anything much while I'm using the camera, but if I it's all moving all over the place. Okay, so try to align it there, solder it on, and now we have a jumper which we can use for bridging to ground and put it into bootloader mode. Alright, so in order to do that, what I need to do is find some ground elsewhere on the board. And there are a couple of test pads. There's even a test pad that's marked ground on this particular version. So just over here, see it's got G and D, and there's a little test point right there. And that would be a convenient place to put it down. And there's also this big solder pad right here, just there. So I think that's probably a convenient place to connect. So you just need to find somewhere that there's ground on the board. So what we can do now is grab our little USB to serial converter with the adapter on it, and it's all powered up. Now I'll get it ready so that it's aligned. It needs to go in this way. I'll just hold it over here. This is all a bit tricky. What you could do is solder another jumper onto ground and put a switch on or something if you like. But now if I find that ground connection, which is just there, I hold it against it, and then while I'm holding it, I slide in the USB to serial adapter and then let go of it, and we now have the slamfer running in bootloader mode. So now we can use this to load whatever firmware we like onto it. It's a little bit of fiddling around for this particular model just because of the lack of easy access to GPIO 0, but not too bad. And once you've done it the first time, you can do over-the-air updates. So you only have to go through this once. And then once you're done the first time, just use the soldering iron to remove that. In fact, I'll do that right now. I'll unplug the adapter, chuck this back under the microscope, and just heat that joint, take off the jumper, and it's all back out again. Now to put this back together, you need to make sure that this long stalk button goes through the hole in the case. So just rotate the PCB to align the button with that hole, and then the back goes on. Now it's actually easy to put this on in slightly the wrong place and then have trouble with the screws. I've made this mistake a couple of times and wondered what was going on. These little screw holes don't align with this pair of holes. They align with this pair of holes. So what you do is you just put the back cover on so that it's aligned with the small holes, put the screws in, screw it back together, and then you're all done. Then you've got your own firmware running on it, and you can do over-the-air updates from that point on. And now for the B1. This one's even more unusual than the slamfer. This is the light globe with all of the control built into it. So it's intended to be sort of equivalent to something like a Philips Hue or a LifeX globe. And when you first get it open, or out of the box, you might wonder, how do you even open it? And you have to do something that makes you feel like you're going to break it. But it's okay. Now, if you do break it, don't blame me. But basically what you have to do is unclip this cover right here. Now, there are no screws, there's no way to get into this. So all you do is you firmly grasp it and you sort of jiggle and twist and pull, and the cover just clips off. And that's all there is to it. It's really deceptive. You might think that you can't get this open, but it turns out you can. Now, there are a few very interesting things about this. Because this has the lamp integrated into it, there is a really big issue with heat. And you see this with all intelligent light globes, and in fact all LED globes. What they need to do is try to make the globe run as cool as possible. The PCB in this is an aluminium based PCB, so Normal circuit boards are made by sandwiching copper on either side of a piece of fiberglass. The fiberglass acts as the mechanical base and it insulates the two sides. In the case of this PCB, it's actually a slab of aluminium and then there are layers on top of that. And that provides a really good conductive path so that heat can then pass very easily through it. So instead of just having a PCB with heat sinks attached to components on the PCB, the entire PCB becomes a heatsink. So that's quite interesting. And you can see on here that what they've done is used a variety of LEDs in order to be able to reproduce different colours and still have bright white. You can see that there are pairs of LEDs here, and without knowing the details, my guess is that these are probably pairs of warm white and cool white LEDs. And then these ones in the middle here are RGB LEDs. And the idea is that what you can do is produce a fairly high level of illumination just with the white LEDs, and then you can use the RGB LEDs to tinge it to different colours. So overall it's quite an interesting little device. Now this one does not provide the nice simple 4-pin connection. So we need to figure out how we're actually going to connect to this. Now there are some test pads along here, and let's put that under the microscope and see what we can work out from there. I'll get this up high so I can get some focus. And if we look at these test points, which have very poor silkscreen on them, you will notice that there are actually 4 test points that are in the same order as the regular 4-pin header that we need to use for everything else. And look, it's got GPIO 0 right there. So what that gives us is all the connections that we need all in one spot. Now, because it's on that aluminium-based PCB, there are no holes through it in order to put the connector on. But we can still solder onto it and then remove the connector later once we've got the firmware in there. If I get a standard 0.1 inch header, and if we just stick it around about here somewhere, we should be able to tack solder that on. So let's do that. I'm going to grab a bit of trusty blue tack and then get this header so that it tries to hold it in just the right place. We want it to be overlapping from the 3.3 volt pin and then RX and TX and down to ground. Let's solder that sucker in place. So just straight onto the pad and then work our way up. So we've now got connections onto 3.3 volts, RX, TX and ground. And now I'm going to get that little orange jumper wire that I've been using for everything else, and I'll tin the GPIO 0 pad and solder that into place. And this is what I'm going to need to use in order to put it into bootloader mode. Because there is no external button on this, there is no other way that we can get this into bootloader mode. So now I'll get the blue tack out of the way. So we have our header for the serial communications, and we have 3.3 volts at this end, ground at that end. So if we have our header and it's aligned this way, that is correct. So we have ground at the top, 3.3 volts at the bottom. Now we just need to find somewhere to pick up ground in order to put it into bootloader mode. And let's see what we can find. Now, of course, we already know that we've got ground on this header here, so we could just use that. That'd be the easy way to do it. And look, there's a little thing over here that's labelled GND, so that's a ground connection as well. So what I could do is bring the jumper around, hold it against that point there. So back to the normal overhead camera, I'm holding the jumper in position, and then we insert our adapter. It powers up and remove the jumper, and this is now in bootloader mode. So once again, we've now gone from brand new out of the box to ready to flash. Now in this particular case, you would probably want to remove the header after doing the flashing. So what I would do in this case is install test motor or whatever firmware you want, and then go through and remove these connections, return it back to its normal factory setting. I will remove the little header, and then I'll just apply a little bit of rotational pressure while I lift this, and then come down to the other end, rotate slightly the other way. We've got to clear that in now. Basically just work backwards and forwards, wriggling, and you get it all off. Now you can see here that I've left a little bit of a bridge across a couple of those connections, so I'm just going to heat that up, reflow it to get that off. And if we wanted to do a bit of a nicer job, I could get some solder wick, pull some out here. So solder wick is stuff that you just heat up on a joint, and the solder flows into it by capillary action. So I'll just lay a little bit of it across this joint and put the soldering iron onto it to heat it up. You can see it's sucking up all the solder off those connections, and leaves a little bit of a mess because of the flux in it, but all of the solder is removed from those joints, so you don't get bridges and things across it. Doesn't look as nice as it did from the factory, but that'll still be fine. It won't short circuit. And now to put this back together, we want to get this cover back on. It's a very simple process. You just get it aligned once again and push, work your way around, and now it's all clipped into place. So we could now screw this into a light socket, and it'll be running the firmware that we've just updated onto it. Finally, let's finish up by looking at probably the strangest Sonoff format of all, the Sonoff Touch. This is a replacement for a wall-mounted switch, so you take off your normal switch, connect this in place, and then it gives you control over lights or whatever you would normally control with it. So you need an active and a neutral, just like with any normal Sonoff, and then it gives you a switched output. It comes in US and European formats. So let's start by having a look inside this one. I'll just get the wall mount bracket off, and the front cover pops off. So to actually open it, you can usually just do it with your fingers like that, but if you can't, all you need to do is get yourself something like a little flat blade screwdriver, put it into the gap, and then you can lever it up. So it's pretty easy to get the front cover off. What you find inside is that this is just a plastic cover. There's nothing to it. And then there is a little subboard on the front. Now it's attached with adhesive along the top edge here, and in the bottom it plugs into a little 4-pin socket. So to get it off, what you might have to do is sort of start from the edge and apply a bit of pressure and twist, and you'll be able to, but you need to sort of brace yourself, because if you pull it and the adhesive gives way quickly, you might end up bending the PCB, which is going to bend the socket, so that's not good. So make sure that you brace your fingers carefully, wriggle it off and break it free from this end so the adhesive is off, and then we can unplug it. And there we have the little control board, and then the main board in the back. So in the case of this is the US version of the Sonoff Touch. The board in the back basically contains the power supply section and the high voltage switch, and then the front contains the actual touch surface itself, which is this little white rectangle. You can see the LED, which shows its status, and on here is one of those little modules with the ESP8285 on it, not the 8266, but it's functionally equivalent. Yeah, there are a couple of other interesting things on here, but before we go any further, it's worth noting there is the classic 4-pin connector right there, just waiting for us to solder a little header onto it. But let's chuck it under the microscope, see what other interesting things we can spot on here. So there is the ESP8285 on the little module, and there is the 4-pin header, ground at one end, 3.3 volts at the other, RX and TX in the middle. Now there's another little chip on here which doesn't have any markings on it that I can see. That's actually the touch control IC. So on the other side of the board there is this touch sensor with a couple of connections that go through here for illumination purposes. And you can see if we look just in the corner down here, this little via comes through from the other side of the board, and that is where the touch sensor is connected from this side. So the touch sensor comes through here, it runs through a 1K resistor into this IC, and this IC is what's doing the actual detection. So when you grab the touch switch and you touch it like this, it's doing like a capacitive sensing, and that is all being managed on this little IC. So the ESP8285 is not doing that detection. The IC does the detection and then sends events through to the microcontroller, which then detects that you've pressed something. Now, what that means is, once again, like some of the other models we've looked at, there's no button here on GPIO 0. The touch sensor itself is handled through that external chip. So we still need to be able to pull GPIO 0 low. Now, let's see if we can find it. Drop the focus here. And just like on many of the others, let's find pin 15. So there's a little marker up here. Pin 1 comes down and across. Pin 15 is the second one from the end just in here. So putting my multimeter into continuity mode again. And let's see if we can find where that comes out. Now, I can see a pretty obvious candidate, but let's just assume that we knew nothing about this device. And we want to find the connection. So I want to find continuity from this pin here. And then I'll just, well, first one, that one there is obviously the antenna, so that's not going to be it. But if we just touch on here and then run along, we don't have anything. From here, run along, and oh, we've got continuity there. So this connection from the edge of the module is connected to GPIO 0. So we know that that is a GPIO 0 connection there. And then if we follow the trace up here, we can see it goes to the end of this 10K resistor. So that is probably a good place for us to pick up GPIO 0. So while I've got it right here under the microscope, I'm just going to grab the soldering iron. It's nice and handy now, so might as well do it while it's here. And we'll just touch the end of that resistor with the solder. That'll prime it for connecting in this little jumper. So the same jumper that I've used on every one of these boards, solder it to the end of the resistor, and now we have a connector on GPIO 0 that we can use to pull it low. Just put that to ground and we're done. Now, one of the things you have to be careful with this particular model, you can fall into a trap here, is if you take this PCB out and you simply solder a 4-pin header in place just under here, which is the obvious thing to do, you will discover very quickly that you have a clearance problem. Now, if you look at the position of this, it's slightly offset, but almost directly above or opposite the 4-pin header. Now look in here. The 4-pin header, directly above it, is this big connection here. Now if I grab some calipers and we measure the height of that connector, it's about 8.5 millimeters. So if we mount this below the PCB and then try to put this back in place, that is going to protrude down 8.5 millimeters. But right where we want it to go, there is this big solder connection right here. So if we were putting it down just to the PCB like there, we've got about 9 millimeters of clearance. But over here, we've only got about 6.7 millimeters. So there is not enough clearance to put this header in place and still have it clear this. Now, you can actually buy low profile headers, similar to this, but they just don't stick up as high. And I've got a bunch of those. So that's one option as well, but they're not as easily available as these standard height headers. Whatever you use, just make sure that you look at the mechanical clearance before you go soldering it in and then have trouble putting the switch back together. What you can do is just leave it out entirely. So if you have some kind of an adapter with pins on it like this one, and we've got 3.3 volts at that end, ground at that end, and you plug it in, all we have to do is apply a little bit of pressure and that will make a good electrical connection. And first we need to put it into bootloader mode. Just around here you can see a very handy label of ground on there, so what I can do is just bring this jumper around, hold it against the ground pin, and then I've just got to line up 3.3 volts on this end, ground on that end, push it in, let go, and now we have this module in bootloader mode and we'd be able to upload new firmware to it. Then when the job is done, just pull it out, unsolder this wire and push it back in, use the existing adhesive to hold it in place and clip the cover back on. So let's just have a look at the US format switch and see how that compares to the European format. See if there are any differences there. Just get the cover off and you can see here that the front of the module is very similar. It's got a separate standalone board on the front. It's a different layout to the American one. You can see that the physical shape of it's different, the connector is in a different place, and it's stuck down with adhesive on the front in a similar way. So I'll start by just levering that adhesive off. Get that off, and it's unplugged. It's got the same sort of little 4-pin header. Once again, the power portion of the circuit is in the bottom of the board, and we have the 4-way header here, and just like before we have the module in here. So we chuck this back under the microscope like the other one and orient it so that pin 1 is in the top left, and what we can see is that just down here that's GPIO 0, and we've already worked out on this module that this pin here is the one that goes to GPIO 0. So we could very easily just solder the jumper on here and then the job would be done. We'd be able to just put the header through, same as with the other one. We've got ground at one end, 3.3 volts at the other, and if we had the jumper in place we could push it in, hold it sideways, it'd come up in bootloader mode, reflash it, reassemble it. So reassembly is just reverse the process. Plug it in, push it down into the adhesive, clip the cover back on, and as you're putting it on, make sure you get it oriented around the right way because it's not clear which way this is meant to go. If you look at the front of the cover, you'll see the little blue Wi-Fi symbol here. The status LED goes behind that, and if you look on the PCB you can see the little status LED just there. So make sure that you orient it so that that aligns with the LED, put it together, clip it closed, and you're done. Make sure you do the same thing with the European style. So if that is plugged in, you can see the status LED there, the symbol is there so it would go that way, not that way. So with what you've learned in this video, you can now reflash any model of Sonoff, even new ones that haven't been released yet, as long as they use the ESP8266. In fact, it's not just Sonoffs. If you've got a device based on the ESP8266, you can trace through those pins, put it into bootloader mode, and then reflash it. So this little device that I made for my own purposes, I'm going to make these available. It's only a PCB and a couple of connectors on it. I'll put it up for like $4 or something on my site. So if you want to reflash Sonoffs, this could be handy for you. Otherwise you can make up a cable yourself just using the diagram. And if you want all the information about this, including pictures with the pinouts of all the different models, make sure you're not just watching this on YouTube. Have a look in the video description. Go to the page that is linked there, the episode page on the SuperHouse website. And also of course, for my patrons, everybody that supports me on Patreon at any level, they get a discount code. I send those out regularly, so you can get a discount on the $4 adapter. So thank you very much for watching. And if you have managed to flash another type of Sonoff that I haven't shown here, and put details in the comments below or comment on the page on SuperHouse. And there'll be more videos coming soon because I've been working on some really cool new assistive technology projects with my friend Chris Fryer, and those are pretty awesome. So in the meantime, go out and make something cool.